All right, hello, welcome back. We're on to the second video on inverse functions for Chapter 5, and I thought I'd start out with a real-world example. And so on the screen you can see that the function f of t describes the height of a corn after t days of being planted, all right? And so the question says find a formula for the inverse and explain the meaning. And so this is the new part that I want to introduce you to. And so let's just do a real quick review. You should be very good at this by now. The first step is always to change from f notation, function notation, to y equals. So I'll go ahead and write it like that. The second step, and I'm going to go ahead and change to x to make it more consistent, is to switch the x and the y, so 6 plus 2y. And the third step is to solve for y, and so we subtract the 6 and we divide by 2, so we get 1/2 x minus 3. All right, and so what we've found is the function that describes the inverse. So let's talk about the meaning of it because that's important. And so if the original function said that the height of the corn is a function or depends on how long it's been planted, all right, that's the original function, then this function is saying that the time it has been planted is a function of the height. All right, so let's go ahead and just make real quickly a table of values here. And so for the first one, we have t in the x column and h in the y column, and so 0, 1, 2 means that after 0, 1, 2 days, these are the heights of the corn. If we look at the inverse function where the height and the time change places, now we're saying that we can look at the height of the corn and predict how long it's been in the ground. All right, so now we have 6, 8, 10 go to 0, 1, and 2, and so the ordered pair 10, 2 means that when the corn is 10 inches tall, it's been in the ground for two days. All right, hopefully that helps clear it up, this idea of inverse functions. This next section I just want to talk to you about some notation, and so I'll write 17 a little bit bigger, it's hard to see. We're saying f of t is the function 2/3 t plus 1, and they want you to find f inverse of 5. And so this is really, really important that we're clear what they're asking for. If I asked simply for you to find f of 5, you would plug in 5 and get an answer. But that's not what I'm asking. I'm asking this, and so when you see this, you're thinking to yourself, this is what you're thinking, I want to find the t where f of t is equal to 5, okay? So in other words, we're going to solve for t with this notation, and so the way we do that is we set this equal to 5, we subtract 1, we get 2/3 t equals 4, or t equals, sorry, t equals 3/2, 6. Very good. So what did we find? We found that if we go back to the original function, that if we put 6 in the original function, we should get out 5. So let's check it out. So f of 6 means to put 2/3 times 6 plus 1, and 2/3 of 6 is 4, and 4 plus 1 is 5. Sure enough, it checks out. Okay, and you could practice. I think you have some homework problems like this, but the idea is the same, that when we ask the question this way, it's like we're asking it backwards. F inverse of 5 is saying solve for t so that f of t is equal to 5. All right, great. So the last thing I want to talk about is something brand new, which is called composition of functions. And we're going to look at composition of functions specifically that are inverses of each other. And so I'm going to put, for an example up on the board, I'm going to give you two functions, and I'm going to say f of x is equal to 2x plus 1, and g of x is equal to 3x plus 5. All right, so with f of x, if I asked for f of 2, everybody would say, oh, that's easy. That means to put 2 in for x. And if I said, what is f of b, then you would say, oh, no problem. That means to put b in for x. So this new notation now has two sets of parentheses, right? And instead of f of 2, f of b, it's going to be f of a function, right? So we're going to, for instance, say f of g of 3, and in words we say f of g of 3, and here's what we do when we compose functions is we start with the inside. We always start here, okay? And we put 3 into g, so that's easy enough. 3 times 3 plus 5, and that's 14. And then we put 14 into f, and 2 times 14 is 28 plus 1 is 29. Okay? So this notation, when we see it, oh my goodness, f of g of 3 means to start here, get a value, and put it into f. So now I want to talk to you about what it looks like with inverse functions. All right, so I'm going to give you two functions that are inverses. So f of x is 2x minus 6. I think we've had this one before. And the inverse, f inverse of x, is 1/2 x plus 3. All right, and your job is to find f of f inverse of 8. Okay, so just using the model we did before, we're going to start here. And f inverse of 8, when you have f inverse, is to simply plug in 8 into the inverse. All right, so half of 8 plus 3 is 7. So this part is 7. And then f of 7 means to take 2 times 7 minus 6, and you get 8. And if the 8 looks familiar, it should. Okay, let's try it with one more. Just because it worked on that one doesn't mean it will always work. All right, so let's this time do 0, f inverse of 0. Right, so we're going to put 0 into the inverse, so 1/2 times 0 plus 3 equals 3. And then let's do f of 3, and we get 2 times 3 minus 6, and we get 0. So here is the concept you need to take away, that if we have two functions that are inverses of each other, and we compose them like this, that it's as if the inverses undo each other, and what we're left with is what we started with. Okay, so you're going to use that in some of your homework problems, and I will see you in class.